This video is about the Rankine cycle. It is very important to understand because it depicts how maximum energy can be extracted from steam to achieve maximum mechanical work by turbine. Increase in work done by turbine increases generation of electricity. Let us go through tsdiagram for steam, which shows different phases of water. Here, T on y-axis is temperature and S on x-axis is entropy, which means degree of randomness or disorder. Left-hand side of curve is called saturated liquid curve. This curved line separates water in subcooled liquid state and water vapor mixture or wet steam state. Topmost point of curve is called critical point. It indicates that any further addition of energy will convert liquid to dry vapor without undergoing into two-phase transition, that is, wet steam phase. Likewise, right side of the curve is known as saturated vapor curve, which separates wet steam and superheated steam. In graph, blue color shows subcooled liquid and red-colored area shows superheated steam. In between these two, the pink area shows liquid-vapor mix. Now, if we see the Rankine cycle in context of different processes taking place in boiler and turbine, it will help in understanding how superheating and reheating of steam helps in getting more work by turbine and thereby generation of electricity. In thermal power plant, coal is burnt in boiler to provide heat energy to water, which converts water to steam at high temperature and pressure. Steam is sent to turbine where heat energy of steam is converted to kinetic or mechanical energy, which rotates the turbine. As a result, generator shaft coupled with turbine shaft also starts rotating, and this generates electricity. Here we can see process flow and energy transformation diagram. After expansion in turbine, temperature and pressure of steam drops and steam becomes wet, so steam is sent to condenser for condensation. Broadly, there are four processes in Rankine cycle as shown in the graph. Process 1 to 2. Boiler feed pump feeds water to boiler from low pressure to high pressure. Process 2 to 3. The high pressure water enters the boiler and is heated to become saturated vapor. Process 2 to 3 is constant pressure heat addition in boiler. Process 3 to 4. The dry saturated vapor expands in turbine, due to which temperature and pressure of vapor drops. Point 4 shows that dry steam converts into wet steam. This process takes place in turbine. Process 4 to 1. Wet vapor then enters condenser, where it is condensed at a constant pressure to become saturated liquid. Process 4 to 1 is constant pressure heat rejection, which takes place in condenser. Condenser is also termed as a heat sink. Rankine cycle helps in harnessing maximum power from heat source by increasing temperature differential between heat source and heat sink. When steam comes out of the boiler drum, it is in dry state shown at point 3. It is steam after boiler drum before superheaters. As we see, it is at the border of two-phase region of steam and water. When steam expands in turbine, the steam becomes very wet, as shown in point 4. Water droplets present in wet steam hit the turbine blades at high speed, causing pitting and erosion. It decreases the life of turbine blades and efficiency of the turbine. To overcome this problem, saturated steam is sent to superheaters. After passing through various superheaters, steam gains heat at constant pressure and becomes superheated. This we can see in the graph that steam at point 3 moves to the right to the point 3' in superheated zone. After expansion in HP turbine, steam becomes dry and saturated at exit of turbine as shown at point 4'. So process from 3 to 3 dash indicates superheating of steam and different stages of superheaters, whereas process 3 dash to 4 dash is expansion of superheated steam in HP turbine. Additional work done by steam is shown as 3 to 3 dash, 4 dash to 4. Advantages of superheating can be summarized as: state of steam improves at exit of turbine from wet to dry state. In graph, it shifts from 4 to 4 dash. No pitting and erosion of turbine blades due to dry state of steam. Work done increases due to superheat. See additional area 3 to 3 dash, 4 dash to 4. Increases turbine efficiency and overall efficiency. Now the exhaust steam from HP turbine outlet is called cold reheat. This cold reheat is sent to reheater in the boiler. Here we have shown two reheaters. First is called primary reheater and second is called final reheater. Reheaters are located in flue gas path, so cold reheat is first sent to primary reheater and then final reheater. This process increases temperature of steam at same pressure. This heated up steam is called hot reheat. It is then sent to IP and LP turbine where it rotates turbine shaft and undergoes expansion. Due to expansion, temperature and pressure of steam drops. In graph, point 4 dash shows cold reheat entering reheater. On heating up there, it becomes hot reheat. Point number 5 shows hot reheat coming out of the reheater and sent to IP turbine. After expansion in IP and LP turbine, temperature and pressure of steam drops to point 5 dash. Parameters for 210 megawatt are listed here to get an idea only. They vary according to design, make, etc. So advantages of reheaters can be summarized as: it increases work done as shown in the graph. It increases thermal and overall efficiency. It reduces feed water quantity and so the power of BFP, that is boiler feed pump. It reduces size of condenser and boiler. It increases turbine life and reduces fuel requirement. That's all about the Rankine cycle and the effect of superheat and reheats. Stay tuned for more such videos.